All right, gang, we're going to do some discovery right now, which basically means let's practice this math. Let's do some repeated exercises and really see if we can work it out. To do this together, you're going to want to grab pencil and paper because you're going to do these exercises on hand. I'm going to show you some questions, just like the ones that we're going to look at right here. Then you're going to pause the video and then in a moment, when you unpause it, I will go through the questions with you. We'll do this twice for a couple of different sets of questions. Here's our first set. Let's go ahead and pause the camera, take a look at them yourself, and then we'll do them together. Okay, so let's look at doing these conversions together. We're going from milliwatts to decibels. So what does that mean? It means we need to be very familiar with our rules of 10 and 3. So 20 milliwatts. Remember, the milliwatt side is the multiply side. So 20 is 10 times 2 is going to give me 20 milliwatts. So we convert that to its equivalents and add them on the decibel side. So that's 10 plus 3, which is 13 decibels. How about 8 milliwatts? Well, that's 2 times 2 times 2 milliwatts. So that's 3 plus 3 plus 3 equals 9 decibels. And again, we'll go ahead and put this M out there because we are talking about dBm. 2 watts is 2,000 milliwatts. Don't watch out for that. That could be sneaky. So that's 10 times 10 times 10 times 2 is going to give us 2,000. So that's 10 plus 10 plus 10 plus 3, or 33 decibels. Okay, how about the other way around? 23 decibels to its milliwatt equivalent. Okay, so 23 is 10 plus 10 plus 3. So we flip that over into the milliwatt side. So now we're going to say that that is equal to 10 times 10 times 2, which is going to be 200 milliwatts. All right, this last one's a little tricky. Negative 13 dBm. So that means this is negative 10 minus 3. All right, that's okay though. That means on this side, that's 0.1, right, times 0.5, which is going to be equal to 0.05 milliwatts. All right, so that's the process that we're going through in order to convert from one to the other. Here it is in a little more pretty format, just seeing the same values right there, but just all typed out nice and neat. All right, gang, now let's go ahead and take a moment and look at our power conversions going from dBd to dBi. Go ahead and pause the camera again, and we'll do it together. Okay, so dBd to dBi. Remember, the rule dB, it's the 2.14 dB decrement, dB increment. Remember, those are our two ways that we could go. So how many dBd is 7.24 dBi? So 7.24, and I'm going to dB decrement, so minus 2.14 is going to give me 5.10 dBd. All right, how about dBd for 13.56 dBi? All right, 13.56 minus dB decrement, 2.14, so that's going to be 2 for 11.42 dBi. Ooh, other way around. How about how many dBi is a 3 dBd antenna? So we're going to dB increment. We're adding. So I've got 3 dBd plus 2.14 is going to give me 5.14 dBi. All right, so we're working our way across here. How many dBi for an 18.86 dBd antenna? Okay, this is not hard. 18.86 plus 2.14. All right, 0, 0, carry the 1, 18, 20. That's going to be 21 dBi. And finally, what is the dBd gain of a 10 dBi patch antenna? I've added some additional words here. The process doesn't change though. So as we look at, again, converting from dB decrement from a dBi antenna, so 10 minus 2.14 is going to be 7.86 dBd. All right, so gang, that's how we convert. Let's see it all with the pretty pictures. Here it is. Again, same process. Remember that same table. You're either adding or subtracting that 2.14. That's all there is to it. One last one. Which antenna has more gain, 2.14 dBi or 3.28 dBd? Remember, it doesn't matter now which way you go. You've just got to pick one. So pause the camera, and then we'll do it together. All right, our last set of questions here. Let's do them together. I like to add, so I'm going to dB increment. And in this case, I can say 2.14 versus 3.28. Well, in order to convert to get the dBi of 3.28, I'm going to add 2.14. Gang, I don't even have to go any further because I know that this number is going to be, it's already bigger and it's going to be even larger. So I'm going to end up with what? 5.42, all right, in terms of dBi. So therefore, this one is the greater. Which antenna has more gain? Again, the dBi or the dBd? Well, we're going to, if I increment this, once again, this is already larger. I know it's going to be bigger, but sure, we'll add 2.14 to get the dBi out of this. And therefore, we'll get, oh, wait a minute. We're not having an equivalent match here, are we? On this one, notice that the reference is saying dBm rather than dBi. We can't actually convert from one to another. Oh, watch out for this, gang. This cannot be answered in this case. We actually don't know. If it was dBd, we could convert and say it's bigger. But, sorry, right there. That value is not an antenna value. We cannot, one's versus milliwatts, the other is versus an isotropic antenna. They have nothing to do with one another. Yeah, they're both logarithmic scales, but we cannot compare them to each other. That's a typo on the vendor box, and you need to figure out which one it is or buy a different antenna. Last one here, 4.18 dBi versus 3.14 dBd. Once again, I'll do the increment, 2.14 to convert it to dBi. I also prefer doing that because remember our EIRP measurement is done based upon dBi. So that's going to be 5.55. Therefore, this is the larger one. So looks like the smaller number, but turns out it has the more gain. All right, so let's see that one last time with pretty pictures. Awesome, that's the conversion process, how we compare antenna to each other. Thanks for doing the discovery with us.